Hi everyone, I'm Jibin. I'm glad to share with you our work made in infilling with user-provided structural context. Music infilling has been well done by many researchers. They don't contain the functionality of letting user control the generated content. However, it's not always match up the practical composition requirements. Sometimes, the composer wants a model or tool assist them creating music based on the control in their mind. For example, this composer have done 3 musical phrases A, B, B prime, and want to infill another between B and B prime. He expects the new one sounds like A, we normally say A prime. In this scenario, we need a model to generate control content. We can tell the model we want something sounds like A, and the model generates the result A prime. We use pop 99 with structural label as our dataset. It contains mini song with 3 tracks, melody, bridge, and piano. We rebuild piano track to simplify the data. In each song, the similar phrases are marked with the same letters. For example, if the first 4 bar and the 8 to 12 bar sound similar, they are marked with A. We translate data to Remy-like tokens, and add a structural token behind each bar token. We use transformer as a backbone model. The prompt and the user-provided context are the input of decoder and encoder respectively. Take insight to the decoder. The information extracted from the encoder is passed to the decoder with the close attention. Since each song may contain multiple user-provided contexts, we use structural token to indicate the current context and pick the exact part of the information in close attention. To evaluate the result, we use 3 objective metrics. There are 2 goals for these metrics. First, we have to make sure the connection between the result and the prompt sounds fluent. And second, we expect a correspondence can be found between the result and the user-provided context. Therefore, for local smoothness, we have 2 metrics called pitch class histogram cross entropy and the grooving pattern similarity. The first one represents the pitch cross entropy. The lower value, the more smooth. The second one is used to evaluate the rhythm similarity. We expect the higher value because we want the rhythm not to change too much. On the other hand, for structural correspondence, we evaluate with melody distance. The close distance of 2 melody lines means that they are similar. We expect the generated content sounds like the user-provided context. And here is the result. We compare our model with VLI and GS model. For H and GS, all models perform well except GS model on H. And for D, our model have better score than other baselines. That means the content generated by our model is more similar to the user-provided context than other baselines. Besides, in user study, we let the subjects evaluate the melody fluency, rhythmic fluency, structural correspondence, and the overall feeling. The subjects are separated into 2 groups, professional and amateur. We can see our model get higher score in each aspect. It looks really not bad. But when we take more careful to the result, we find something weird. The subjects think the result generated by our model is good as a real music. Then we go back to check the generated songs. We found our model often directly copy the user-provided context as a result. We call over-imitation. And due to the less variance of past songs, it makes the copying sound normal. The problem is reported in our paper. We find a solution of augmentation after formal submission. It's training the model by considering the loss of preceding prompt. While the result is not included in the paper, we put that on the demo site and GitHub. Okay, let's wrap up. In this work, we propose the model generating the infilling content with user guidance. However, currently we use the whole music segment as provided context. We think there will be a better way to do that. Thank you, my presentation ends here. If you are interested in our model, you can check the demo on this website.